Hey, welcome back to part two of the chapter review. Get myself set up here a little bit. Hey, welcome back to part two of the chapter review for chapter 6 on ratios. I did forget to do question number 11 last time, so I'm just going to do that one real quick, and I'm just going to put it right down here at the bottom. Harry walked his dog on a trail that was 240 meters long. I'm going to go ahead and make myself a little box here. I know I'm going to need it. He walked on a trail that was 2,400 meters long, so I know I'm going to be dealing with meters. And how many centimeters did he walk? Holy Hannah. Centimeters. All right, well, I know that a meter, in 1 meter there are 100 centimeters, and he walked 2,400 meters, so 2,400. And so I'm going to put that in, and I'm going to multiply diagonally. 2,400 times 100 equals 240,000. And then, of course, we're going to divide that by 1, which is really just the same answer, as you know. 240,000 centimeters is what he walked. And it makes sense because for every meter, there's 100 centimeters. So you're really just tacking 2 zeros on the end of that when you multiply by 100. Okie dokie. All right, let's flip to the other side. Get this set up. All right, the old, this question is actually not written very well, but bear with me. I know I'm going to use a box. I'm going to go ahead and make one because these are all about these ratio and rate problems. On Earth, let's see, we got Earth and Mars. I'm just going to get set up here. On Earth, a 180-pound person weighs only 80 pounds on Mars. Well, that doesn't make any sense. I think what they're trying to say is on Earth, a person weighs 180 pounds, and on Mars, they weigh 80 pounds. So 180 pounds on Earth, 80 pounds on Mars. If you only weigh 60 pounds on Mars, how much would you weigh on Earth? So here's what we're looking for right here. Again, labeling, getting them in the right boxes. Multiply diagonally, and then divide. So I'm going to get my calculator. There we go. 180 times 60. And then we need to divide that by 80. And we get 135. And of course, that's pounds, because these are all pounds. LBS. LBS. So we got Earth, Mars, 135 pounds. Okay? And it makes sense. All right? 180 to 80, 135 to 60. Okay, let's move on. Dave Onzel has an active heart rate of 30 heartbeats in 15 seconds. So he's got 30 heartbeats in 15 seconds. What is his heart rate per minute? Well, I've got seconds here. I don't have minutes, but I know that there are 60 seconds in a minute. So I've just completed my box. Kids struggle this one all the time. So you've got, wish I could get that to stay on. I know one of you could tell me how, but you're not here. 30 times 60, we multiply diagonally, and we're going to divide that by 15. Divide by 15, we get 120. That makes sense. This is a quarter of the minute, right? So a quarter of it would be 30. Half of it, he'd be 60. And so he has 120 beats. That's per minute. Per 60 seconds, it's the same thing, right? So your unit rate there is the minute. Okay, what is the missing value? Can you see it if I make it that small? I think you can. These are pretty straightforward questions. We know we have a ratio here. So we have 10 to 16, and now we've got x and 24. And, you know, we need to figure out what is x. What is x? So they're already put into the box for us. All you have to do is do the math. So we will multiply diagonally here, 10 times 24. And of course that is 240. And we're going to divide that by 16, our other number. Divide by 16. And we get 15. X equals 15. So I'm going to go write that over here. X equals 15. Okay? All right. Let's move on down. We have a rectangular prism with a height ratio of 1 to 6 to 12. Oh boy, that's a double ratio, right? So we have to make a double ratio box. So instead of one cross, we end up with the double cross. And again, you still have to label things. So I was working through with one student. She forgot to label them and didn't know what her answer was. So this is still length, width, height. Length, width, height, 1, 6, 12. 1, 6, 12. Okay, what is the height measurement if the length is 4? So now we've just got this double box thing here. So I'm going to go ahead and set my calculator here because I'm not going to be worried about that box right now, correct? I'm just worried about the single. 4 times 6 is 24. 24 divided by 1 is 24. Okay, now I'm going to take and block off that other box. I don't need that one now. Now I'm just going to complete this other one. So 24 times 12, right? I can't see. And then I'm going to divide that by, what's the other number, folks? 6 is 48. And it makes total sense. 1 to 4, 6 to 24, 12 to 48. So the height is 48 centimeters. Okay. All right. Don't forget that double cross thing. This one here is actually a unit rate problem on these shirts. I don't know if there's one like this on the test or not, but which is the best buy? So basically you got to figure out what the unit rate is for each of these shirts. So I'm going to rewrite this because I don't like it in this format here. So I'm just going to say that it's $25.50 and it is for 6 shirts. Now if I want to get that down to one shirt, I'm going to end up dividing by 6 on both sides. And sometimes I just put the fraction bar there too. You can do that if you want. But this 25 divided by 6, of course, is 6 divided by 6, of course, is going to be 1. So we get that unit rate. They kind of cross themselves out. So I have to do the other one, which is 25.50. Better clear that. 25.50, and I'm going to divide that by 6. Figure out what each shirt's cost. It's 4.25, and so that's really $4.25 for shirts. I'm just going to write that down here. This is $4.25 for each of these shirts. Tara said, well, hey, can't you just divide 18 divided by 4? You can. I'm just kind of review the unit rate thing as I go here. So you have $18 for 4 shirts. If we divide by 4 on both sides, these guys cross off. Our new ratio then is going to be 18 divided by 4, 18 divided by 4, and we're going to get 4.5, which in reality is $4.50. So that's a little more expensive. Let me write that so you can read it. $4.50. And this last one, 5 shirts for $21. Okay, so 5. No, I'm going to do this. I like putting the money on the right-hand side. Sorry, or the left-hand side. So $21 for 5 shirts. And go ahead and divide by 5 to get that unit rate down to 1. And I'm going to divide this by 5 too. 21 divided by 5 is 4.2, which really is $4.20. That's the best rate right there, $4.20. This is $4.25 per shirt, $4.50 per shirt. $4.20 is the cheapest. Okay. Lauren took 12 hours to read a 360-page book. Go ahead and get one of these ready. So she took, we've got hours and pages that we're talking about here, hours and pages. So she took 12 hours to read a 360-page book. at this rate, how long will it take her to read a 400-page book? So I got hours, so my 400 goes down here because we're talking about the pages. And I know you guys know what to do now. And I hope you're getting the idea here. You just have to read carefully, make sure that you label your little box, and then put the numbers in. All right, let me get this one. So we got 12 times 400. 12 times 400 equals 4,800. And then we need to divide by 360. Divide by 360, and it equals what? Oh, wait. I know what that means. That's 13.3 hours. 0.33. It's like 13 1/3 hours. 13 hours and 20 minutes, right? Okay, sounds great. So it's 13.3 repeating hours. That's the worst looking H I've ever seen. There we go. 13.3 hours. All right. Next one. Pat wants to enter. I'm going to go ahead and get this set up. Pat wants to enter a typing contest. In order to enter, he has to be able to type 50 words per minute. Pat took 15 seconds to type 10 words. Can he enter the contest? So it looks like we got seconds and words we're going to be dealing with here. Sorry, I'll slide that up. So we're going to be dealing with seconds and words here. So he has to be able to type 50 words per minute. This is going to be like that heart rate problem, because we've got minutes and seconds. So we're just going to stay in seconds and remember that there are 60 seconds in a minute. So he can do 15, let's see, Pat took 15 seconds. He took 15 seconds to type 10 words. Sounds like me. We really want to know how many he can do in 60 seconds, because we have to see if he can do this 50 words in 60 seconds or 50 words per minute. So 60 times 10, get that going here, and we'll clear this out. 60 times 10, right? And then we're going to divide that by 15, divide by 15. Looks like he's only doing 40 words in 60 seconds. So his rate is 40 words per minute. And that's not going to cut it. You need 50 words per minute. Pat, you can't join the contest. All right. But hey, I succeeded being able to type 40 words per minute. You can do it too. All right. This one here has traditionally confused kids, and it's really pretty simple. I just put a whole bunch of questions there to make it look difficult. Test makers like doing that. 5 lemons cost $1.80. Okay. So we could figure out what is the cost per lemon. All this is saying is what's the unit rate. So again, I like the money on the left here. I got $1.80, and that's a ratio for 5 lemons. So again, you can just divide those two, but I just kind of set it up like this to get my ratio down to a unit of 1. So now I have to divide 180 by 5 to figure out how much each of these lemons would cost. 1.80, that's $1.80, and I'll divide it by 5, gives me 0.36. What does that mean? 36 cents. Take a look at it. There's, if I put a 0 and a dollar sign, it would be $0.36. So at this rate, what is the cost of 9 lemons? Now you could just multiply this by 9 if you want. I'm going to do it with the box because, I kind of dig the box. So if 1 lemon, we'll go lemons and dollars here. If 1 lemon costs 36 cents, we want to know how much 9 of them are going to cost. And look, you're really doing the same thing, right? You're just going to multiply, and then you're going to divide by 1, which is going to give you, it's just the same as just multiplying. So you just take that 9 times 0.36 equals $3.24. So, are you with me? Sorry, that's kind of messy. All right, last one here. David hikes. This one's kind of tricky. I like this one. All right, clear this out. Okay, so David hikes 2¼ miles in a half an hour. What is his rate in miles per hour? So we want a unit rate basically. So I'm just going to set it up like this time because I don't know what that unit rate is, but I know that he does 2.25, and this is going to be miles in an hour. So he does 2.25 miles. I switched that fraction to a decimal, and you can do that too. And he did it in a half an hour, so I made that into 0.5. Right? Okay. I could have doubled this too and got to a unit rate as well, but if that's what he does in a half an hour, you could double it to get to the hour. But I'm just going to put it in the box because that's what I've taught you to do. 2.25 and 0.5 hours. How far does he go in 1 hour? Well, look what I'm going to do. I'm just going to multiply that. Sorry, I'm going to multiply 1 times 2.25, and I'm going to divide it by 0.5, which is going to give me that same 4.5 that I would have gotten if I just would have doubled that. But again, you're using the box. You've got a real nice little deal here. It tells you what your labels are. It's miles, so it's 4.5 miles per hour. We just abbreviate that mph. So how long will it take him to walk 18 miles? Well, got miles in hours. We're going to go again. So let's see. If he goes, you can use either of these rates that you have, but I'm just going to say that in 1 hour he goes 4.5 miles, and we want to know how long he can go, how long it'll take him to go 18 miles. So I'm just going to double check here. 18 miles, and this is 4.5 miles. So just making sure I've got my numbers in the right category, otherwise the box won't work. So I'm just going to take 18 times 1. 18 times 1, which is of course 18, and I'll divide that by my third number in the box, 4.5, and we get 4. So it'll take him 4 hours to go that. And if I'm not sure, I'll just take that 4, and I'm going to take it times 4.5. That's the 4.5 miles per hour. So 4 hours times 4.5, it equals 18. You can always double check your answers. Just use that logical reasoning. All right, this last one is the one that throughout the ages has given kids fits, and so I'm just going to walk you through it. If he walks for 7 hours, how far will he have gone? So we're going to go hours and miles, right? Well, we know again that in 1 hour he goes 4.5 miles. And you notice I switched hours and miles and miles and hours. It doesn't matter. We're just making sure we put the number in the right spot. So in 1 hour, he goes 4.5 miles. If he walks for 7 hours, how far will he go? Well, that makes sense, right? This is 1 hour, and he's just going to multiply it by 7. So 4.5 times 7 is going to be 30-something, or 31 maybe, equals 31.5. And then we're going to divide that by 1, which is, of course, the same thing. So he's going to walk 31.5 miles per hour. Okay, well, thanks for listening. Here are the things I need you to remember for the test. Read the questions carefully. Use the box for just about all the problems that are dealing with ratios when you're converting them. One of the exceptions for that is the unit rate problems, which I did over on this side in the part 1 video, where you just want to write your ratio like I did here, 100 to 350, and then you just want to divide by the one side. I'm sorry, this is making fractions in simplest form. You just want to do whatever you do to one side, you do to the other. So that one there, you don't use a box. Simplest form. Equal ratios, just stack them and check the cross products, and then you can do these conversions however you want. But unit rate, remember how we set that up? You're going to divide by the one side to get to a unit rate of 1. Most of the other problems, the difficult ones, are going to be able to be solved using either the King-Henry method if you're doing metric conversions. I also showed you how to use the box there. I do all of my standard measurements using the box. Remember, you will have a little cheat sheet that will be at the back of the test as well. Okay, thanks for listening. I appreciate it. Have a great day.